to another short video. Today we're going to go over some pointers and dynamic allocation and how to dynamically allocate memory, at least with pointers. So just have this little program here. So what we're going to do is basically write a function that dynamically allocates an array of numbers. This function should contain two parameters. Here we have one that accepts a pointer value, pointer variable, and the other is just an integer variable, that is the size of the array. The function should then calculate a sum from this array, and then we're going to store this in another pointer variable and return this sum pointer variable to main to output it. And of course, in our main function, throughout our program, we wanted to handle any leftover data, make sure we delete it all when we need to, or when we should, so that we don't have any memory leaks, memory corruption, anything bad going on, any errors, etc. Alright, so first off, just like usual, I'm going to start off with my main function here. I'm going to go ahead and return 0. And I know I'm going to be needing now some includes. So I'm going to go ahead and include IOStream. And then instead of using namespace std, you can actually do something kind of cool. I don't know if this is better practice, but instead of using the whole namespace of std, what you can do is just use std : and then whatever standard thing you want to use, like cout, cin, getLine, endLine, stuff like that. So now that we've just got set up, maybe let's just get started in the main. So we're going to need an array size. We're going to need to create a pointer. And then we're going to create, or maybe not create, we're going to dynamically allocate our array. And those are the first couple steps. I guess we're also going to have a function called on here. And then we're going to have a print. Okay, so now let's get started with the array size. Of course, we're working with arrays, so that means the size of the array must be a constant. And we're only working with positive numbers, so I'm just going to go with a unsigned int here. And we'll name the size, and we'll just start with a value of like 10. Okay, so now we want to go ahead and start creating a pointer. And so this is where the declaration of a pointer comes into play, basically. Or the new, or I mean, I don't know. Just this is how you declare a pointer. Alright, so we're going to go ahead and before we start, we want to think about our data types as well. So I guess this program doesn't necessarily specify, but maybe we should change this to an array of integer numbers. So this array we're going to have is going to be only integer numbers. Why do I keep doing comments? Okay, so to declare a pointer, first we want to declare the data type we're going to point to. So we're going to have an array of integer numbers. So we want to point to this integer. So now we're going to go ahead and put a star there. Oh god. And then that's going to mean we're pointing to it. And then we're going to create our pointer name. And so I'm just going to name this maybe main pointer. And that is how you declare one, but we want to make sure, because of how pointers work, we want to make sure when we initialize it, when we first declare it like this, you want to initialize it to at least a null pointer so that nothing sketchy can happen. My advice, well, maybe I'll go through this before my advice, but there's quite a few ways we can declare these variables. So let's say, I'm just going to quickly go through this, but you can have it like that. So you have a star right next to the data type here. So it's pointing. So we have this PTR pointing to integer, or we have this main pointer with spaces pointing to it. It doesn't matter. Actually, I shouldn't have space. I mean, so all of these are kind of correct. So you can have 2 spaces, couple spaces. You can have this 1 space. You can have the asterisk over here to point. But essentially, either way we read this, we're going to read this kind of from left to right, or sorry, from right to left, right? So from right to left. So first off, this is just kind of our value, right? So we're just going to have our null pointer is our value of this pointer variable. And then what our pointer variable does is it actually points, right? So, okay, so we have PTR, and then it points, right, with this asterisk. We point with this asterisk to an integer value, or basically a type of integer. And so that is how you declare a pointer. You can do many things with a pointer, but remember the one thing, I guess I skipped over this, sorry. One thing about a pointer, pointers hold a memory address. Hold. So if we kind of remember about maybe passing by reference or anything about reference or anything like that, we use this ampersand symbol. And so if we use this with a variable, this returns an address, or this gives us the address basically of the variable, right? So we have an address now, an address of memory. This is what the pointer value would hold. The pointer variable here would hold some kind of address. And so those are pointers, and that's how you declare them. That's kind of how they're used. Sorry, I think I kind of went a bit out of order there, but let's get on with it. So now that we have created a pointer it has nowhere to point, now we want to go ahead and basically allocate our memory, dynamically allocate this array. So what we're going to do is we're going to we're going to use this variable. And so now we're using this variable with just the variable name. And so when we're dealing with pointers and we just use this variable name here, just like this means this variable is looking for an address, right? We're not looking for any values, not looking at anything like that. We're looking for something, a piece of memory, a piece of address from memory. And so we're going to use this to assign it its memory location. And then within this memory location will contain our whole array, which is how it usually works in general. Everything that runs through the programs, all variables and stuff are stored in memory. So now we're going to go ahead and use this new keyword. And what this new keyword does is basically it allocates it allocates memory. So it basically takes a chunk of memory depending on what kind of memory, and then just kind of save this chunk block specifically for this pointer variable we have here called main pointer. And so we want to make an array. So we want to make an array of integers. So we're going to say a new integer. So we're getting a block of memory that can hold integers basically, and then we're going to make an array of constant size. And so what we've done here, just to go through, is we have our main pointer variable. Our main pointer is just the variable name. We have no star here. So this means it is specifically looking for, or not looking, but we want only to use an address right this. Right? If we were to set this to some sort of value, that could be quite bad. We could be corrupting memory, accessing basically an address, because instead of giving it an address, we would give it a random value. So what we're doing here is taking a basically saved memory location that can hold basically about 10 integers into this main pointer. And so now we have our array here. Okay, so now we have an array, right? Our array is kind of filled with nothing. So maybe let's go ahead and just fill this array with some numbers, some random numbers. And again, we're using arrays. Love our for loops with our arrays. So I'm just going to create a counter, or iterator, sorry. Okay. And so if you have used C-style arrays or other kind of arrays or vectors, any kind of stuff like that that use the subscript, we can actually do a very similar thing here with pointers. And so with this pointer, um, if we kind of do a similar thing, this might be a bit confusing, but if we just type the name here, right, and you might be wondering, well, we typed this name here before, that was looking for an address, right? This is address, right? And so we're typing the same name here, and you might be thinking something about an address or anything, but if we actually go ahead and we can use a subscript here, just like an array, and then this turns into just like a array. Other arrays you may have used or anything like that, but our main pointer is now our basically our with the subscript is now able to access the elements of our array. And so we're just gonna set them to something, maybe just like whatever 2 times our iterator is. So, when this goes through, I will be 0, so we'll put in 0 first, and then I will increment to 1, and then we'll have 2 times 1, and it'll put 2 in, etc. It'll go 0, 2, 4, 6, 8, 10 times. So this guy, I'm gonna loop 10 times. And so now in our main pointer, we actually can kind of use this guy now. And before I quite get into the functions, let's just do some simple couts. So let's just try to do something like this. Maybe we want to output just a couple of the things and a couple of subscripts. Not done. That's going to be out of bounds. And just because we are not using pointers and stuff like that, it still means we can go out of bounds. So we have to be very careful of our array bounds, how big the array is, things like that. Alright, so let's go ahead. If we tried to maybe output some of these numbers, let's see what happens. See if we broke anything. Okay, so we have this main pointer here. And only we can see this first value here. So in this locals thing here, let me close this guy. This one's only going to show our first value here. I wonder if I can do that. Okay, so if I hover over this, it says main pointer at subscript 0 equals 0. Now if I hover over here, if this works, okay. So we have now main pointer at subscript 4, or index 4, we have the value of 8 there. It shows 8. And then if we go here, the last guy, we have main pointer at the last subscript of 9, and we have the value of 18 there. So it looks good. So it looks like we can just basically use this guy just like a regular array now, but now instead we are using pointers. So to get on with the program now, we're going to need to create a function and a couple other things. So let's go ahead and create a function prototype. And now this is where it might get a little confusing as well. Hopefully so far you've been following with the rest of pointers and stuff like that, but we're going to have a function that's going to return a pointer. So remember, our data type of our function is our return basically type of our function. So if we're going to return a pointer, well, hopefully you guessed it, that's right, we got to write the asterisk on there, which is actually called so the asterisk is actually called the indirection operator. So maybe write that up here or something, just like this. Whoa. Okay, I spelled this wrong. Indirection. And so now we're telling this function is going to return something. This is our prototype here, so we're going to tell it what we need to pass. And so based off our things here, we should pass a pointer value, which is going to be an int that points to an int, and then we're going to have just our size, which is just going to be the constant unsigned short int. And so now just to go over a couple more things before we get into the function. Since we kind of just talked about constants, you can actually have a constant pointer, and you can actually have a pointer that points to a constant variable here. So I'm just quickly going to go through both. So we have this constant variable here called size. So if I make an unsigned short int, that's a pointer here. Sorry, I like to kind of keep my formatting like that. But if we have a pointer here, and we set this to the address of size, my apologies. Sorry, what I forgot to do is this. Okay. So we have a variable that is the type of constant unsigned short int. And so if we want to have a pointer that points to that, well, we're going to have our pointer here, size pointer is the name, that points to this data type, right? So we're pointing to the other data type. That's what this kind of means in the declaration. So now we have just a regular pointer. So we have a regular pointer that holds an address of a constant variable. So this regular pointer points to a constant address. And so that is kind of that dealio. But now let's say we want to have a constant pointer. We want to have a pointer variable that does not change, a constant pointer. Well, I'm just going to quickly make one to kind of show the difference. But let's say we just have a pointer that's pointing to an integer, right? Then if we write const after our pointer, then here, let's write, no, let's write the same thing, okay. I forgot. Okay. Sorry, I'm kind of doing this one a bit on the fly. Okay, so I just created a new integer variable, so we are pointing to an integer. But now this pointer is constant. From this point on, if we try to take point and we try to set it to a new variable, you know, if we set m or something, this would not work. We have a constant pointer, so we cannot change the value here. So these are the two differences. This first one, we point to constant value, and then this one is a constant pointer. The pointer value cannot change, or the address. The thing is becoming quite long. So those are, I think, most of the other things. Let's get into the rest of this program here. I'm just gonna go ahead and kind of comment this out. Delete that. Okay. So now that we've got our function set up, let's go ahead and make a function definition. So we're gonna have int foo point. Is that what I named it? No. Sorry, I kind of like this formatting a little better. I'm trying to just practice that, but again, doesn't matter which formatting. You can put it next to the int, next to the name, either or. Okay, so now to get into this function, we've got it kind of set up here. We're returning a pointer value. Let's just get the return statement set up at the bottom here. Okay. So we're going to be taking two parameters here. Again, we're taking in that pointer value. Let's just name it like, no. Like array pointer. And then constant. So we have our two variables now. We've got that int star, and we've got a constant unsigned short int. So now our array or function header is the same as our prototype. Okay, so now that we have that guy set up, we're going to need one more thing. We want to calculate the sum and then in this and basically put the sum into a pointer to then return the sum pointer. So what we're going to need is, you guessed it, another pointer. No, let's just name this one sum pointer. And this one we're just gonna declare it all in one line, which we can do. Up here we have it to null pointer first and then we're using it, but we're just simply gonna do this all in one line. And we are keeping a sum of this, so this guy is not an array or anything like that, it's just one value. And so to actually kind of initialize this value first, we can go ahead and just put parentheses like that by the data type. So we're pointing to this integer that is a new int of the value of 0. And so now we're going to go through this for loop here to start going through our way and calculating this sum. So again, I'm going to make another index, and we're going to have, and we've passed in our size, so that way we loop over the correct amount of times and nothing goes wrong. So here is where a slight difference may come in, because up here we only type in the name, but we use a subscript for these, making this an array. This time, since we have just a value, and to change this value, well, we have to basically make a reference to this value. So again, if we just type in this name here, sum pointer, this is the address. We're going to be messing with the address of memory. That is not what we want. We don't want the address of memory. We want to know the value of this address. So to find the value of this, we want to know what it's pointing to. So if we put the name and then the basically indirection operator here, this is going to take this and then it's going to be like, okay, well, what am I pointing to because of this? So now we are pointing to a value of 0 here, right? So now that we have their value, now we can just kind of use this like a other variable, right? So now we want to create a sum, so we can do plus equals, and then we're going to go ahead and do a similar thing here, array pointer now, and then this guy is going to be accessing the subscripts. So we're going to start at array 1, add that to our sum, go to element 2, and continuously sum and add that guy to our array. And so now we should have a looping sum going, and so now we want to basically return this pointer. So now we are returning this address, right? We're not returning the value, not returning the pointer variable which holds the address. So now we've got our function set up. Let's go ahead and call this guy. And since this guy is returning a pointer, well, guess what? We're going to need another pointer to hold our return value there, our return from our function. So we have this pointer that's pointing to an integer, right? Again, we're dealing with integer over here. So all of our data types are good. And this guy, we're just pointing to nothing yet. So now we're going to have this guy point to that return type. So remember, when you call a function and you return it, you can, when it returns, let me set this up first. And so when you return it, right, it'll kind of return back here, and then whatever it returns, it can assign to the sum. So since we're returning a pointer value, we're going to take that pointer value and put it into our sum pointer to use here in main. So now we want to go ahead and pass through our couple variables. So we're calling our function, and so now we want to just pass through our main pointer because we're passing through a pointer variable, and then we want to pass in that size. So we've got that constant size we're pointing in, and then now we have our main pointer we're pointing in. That basically is this array. And okay, so everything's looking good. We've got a function that calculates and then returns this sum. And then now we want to go ahead and print this. Not sure how I did that, but again. And then we're just gonna go sum is. And so now we want to access the value of sum. If we were to just put the name, this would output, you guessed it, the memory address, hopefully. So this would print out or display the address. That's not what we want. We want the sum value. So we want to know what it points to. So what does sum point to? That is our value, and that is what we want to display. Couple things though is since we have dynamically allocated our array, that means we are responsible for our memory. That means we have to take, we're responsible for any errors, memory leaks, etc. like that. So we have to handle all of our memory correctly. So since we have used this new variable, new correlating with dynamically allocating memory, now that we have this memory, well, we want to basically delete this so this doesn't stay and cause errors, etc. like that. We want to be responsible with our memory, so we want to be able to delete our pointers. And basically, we just do that with the delete keyword here. So to delete our array here, right, because we used our array, we've sent it to a function, and it did its job, it calculated. So we don't need it anymore. So we're going to go ahead and hit delete. We're going to put those brackets telling it that it's an array, and then the name of the pointer here. So this guy deletes, basically deletes, not our whole array. Our whole array that we dynamically allocated, and now we should hopefully be safe because we have cleared our memory now. Now, along with that, well, we've printed our sum, so let's just go ahead and delete our sum as well. Because now we're done, it's already been outputted, and I think we are good to go ahead and try running this program. This is running a lot longer than I thought. But hopefully this covers quite a bit on pointers. And I'm going to go maybe a bit through into some debugging as well. So hopefully that you can kind of see memory and stuff like that. So let's get started with that. Okay, so let's just put some breakpoints. Where do I want to put some breakpoints? Maybe here, maybe there, on there, and here. Okay, so now we've got a couple breakpoints set up. Let's see if this works out. Okay, so first I'm going to show you. So I'll show you these windows again. So now that we are debugging, we have stopped in debugging, we can go to debug, up here, go to Windows, and we have a bunch of windows we can click on. So let's click on this locals. This will show our local variables. So now we have this main pointer here, and we see this value is this address, right? We have 0 times some 8-bit, integer, some 4-bit address. And then we have the, well, basically what value that memory is. And right now it's some garbage stuff. So you can see right here we have integer pointing, right? And then we have integer itself. So this is, again, address value. And so now let's go through this and see what happens. And look at that. Now our first place in our array here, our first, the address that has the, or basically address that is the first element, our value turned to 0, right? That's what we set it to. Alright, awesome, that works. Oh, and so now we went through it again, but it looked like nothing changed. And the reason being is because this window can only show the first value of the, basically the array. It only shows the address value here. So if we go back to debug, Windows here, scroll down to memory, we can just create, you can have up to 4, so let's just create one memory channel, or window. And now we can actually look at our memory inside our program. And so let's just start messing with some stuff. So I'm going to use this thing to reference the address again, right, our ampersand. And what I'm actually going to do is I'm going to see where our actual main pointer variable is in our program. So at 006FF7 the floor, whatever, I'm not going to say that anymore. Okay, at that address, you see we have 4 bits right here. We have these CC, whatever, bunch of garbage around, but we have this 4 bits right here that is perfect because our integer holds 4 bits. So this is going to be the address that this holds. So our pointer holds this 4-bit address. And so if you actually want to do something cool now, what we can do to see this whole array in our memory is this is an address. So now we can just go to this address. So we're going to go 0 times 0, 0. And now this is going to be a little weird because you're asking, well, why am I starting out 0, 0 and not just copy this and paste it? So the way memory is actually stored in your computer like this is called, I think this is what it's called, I guess. I think it's called little endian. I believe that's the right term. But anyway, what that means is that our memory is actually stored kind of in reverse. So we have these 4 bits here, but the way to actually look at this is bit 4. This is bit 3, 2, and 1. So we're starting with 0. So we have 0, 0. To go to the next bit in order, we're going to jump over here. So our next bit is going to be A0. Right? None of these numbers are necessarily flipped, but kind of the order. Right? So we have 0, 0, A0, and then we have CA, and then we have C0. And then if we go to this address, well, boom. Here is our array. Here's the values we have in it so far. We have 4 bytes of 0, 4 bytes of 0, and then we have a whole bunch of bytes that we have yet to fill. This is going to be our rest of our array. So now we are actually at the memory location, so we should be seeing this change every time now. So if we go through and we're here, we should see a new 4-bit of 4 come up. Boom, look at that, it changed. We took 4 bits out, and we got 4. And then we can just go through this. We get 6, 8, 10, right? That's hex for 10, 12, and then 14, and then 16. No, I think there's one more. And then we get 18. And so now this is our whole array, right? We filled all those empty things up. We changed it all. And you can clearly see right there all of our data in our array, right? So remember, this is the address that our pointer variable holds, our main pointer, that's what that holds. But now that all of the values and data that it points to is all right here. Hope that was kind of a little helpful, a little more insight on how pointers work and memory and stuff like that. And so hopefully you can kind of see, well, dang, it'd be super easy to just go one more address over and then mess with this. And that's where you start getting errors, memory leaks, memory corruption, etc., etc. Just bad stuff. So we do have to be very, very careful when we are dealing with pointers. So that's just about it for that part. So now let's continue on. I think we should jump out of this for loop. So yep, let's continue on now into our function here. So now we can see. So if we want to check out some pointer, well, we just do the same thing. We're going to check out where some pointer located. Some pointer right here. So this is now our 4-bit address that has our value or our data in it. So let's go to this address 0, 0. Remember, kind of going backwards. A0, 59, D0. Boom. Here we have our 4 bits for our integer value. So now as you go through this, we should see this guy increment. We just added 0 in there, but now we should add 2. Look at that. Change that guy to 2. And we can kind of just go through. And now remember, we're summing these, right? So we're adding 0 plus 2 plus 4 plus 6 plus 8 plus 10 plus 12 plus 14 plus 16 plus 18. I don't think that's the last one. We should go ahead and exit. So now we have this, right? So that's our value, but remember what we're going to be returning here. We're returning this address, right? So we're returning this address, so we're taking address from here, putting that address back into sum here. So when we go back and we go ahead and actually return, we can see this guy change. So if we look at our sum variable here up in main, we have this 4 bits for an address that's set to 0 right now. Boom. Now we've got that address of our sum. So again, we can look at this address. We go 0, 0, 0, A 0, 5, 9, D 0. Boom. Again, back to where we are. So we've just taken that address from our function, returned that address. Now we can use it to display. Because now we're at our cout. So if we go ahead and use our cout, bring this guy over here. Boom. Works perfectly. Sum is 90, which I really believe is calculated it right. So now we've kind of used our memory. Oops, I did forget one thing here. So let's just kind of go through it. I did forget one thing. So let's check something out. Alright, so we've got our main pointer here, right? Our main pointer has a value. That's our address, right? Let's see what happens when we delete it. Boom. Ooh, what happened there? I don't know. It just took us, it deleted it, put some random thing back in there. And now let's go ahead and look at sum again. So sum is that value. We can even double check real quick. 0, 0, A 0, 5, 9, D 0. Still has that value, so let's just go back. Still has our correct value in there, so now we go back. We're going to go ahead and delete this guy. Boom. Went back to random stuff. Let's see what this actually is. So 0, 0, 0, 0, 8, 1, 23. That is stuff we cannot access. So that must just set it maybe to, I don't know, some kind of thing. But anyway, that was kind of deleted. So now we can see we've handled our memory and deleted it. Except for one thing. There is one guy I forgot to mess with, and that is just sum pointer. So I think if we look up this guy, we can't do it. Dang. Anyway, this sum pointer is still somewhere in memory. We're not able to see it because we are outside of the scope. But basically, we should not delete that there. What am I doing? Can you even actually, no, it's the function. Okay, I think I'm I think I'm confusing myself and overthinking. I believe this should delete itself because we get out of the scope of the function. So because we are in a function, it creates it, and then it should believe it should delete it when we leave that function, so we don't have to do that. This should cover my whole little program on pointers and dynamic allocation of memory. I hope you learned something. We went through quite a lot. Hope that covered the bases, and maybe this can be a nice video to refer to. So thank you so much for watching. Hope you guys enjoyed. Hope you learned something. I'll see you next time. Don't forget to smash that subscribe button. See you next time.